Okay. We have the mirror formula 1 by f is equals to 1 by u plus 1 by v. To solve the problem, I repeat you once again, convex and concave. In the convex, u is always negative, v is positive, f is also going to be positive. These are the rules to be used in the problems. And u value is going to be negative, v value is going to be negative, f value also is going to be negative. These rules will be used when you're doing a problem. And take an example question. Find image distance if an object placed at 10 centimeter away from concave mirror whose focal length is 5 centimeter. Also characterize the image. We'll explain with the ray diagram. First write the data what is given. Given, he said that it is going to be a concave mirror. And he said find the image distance. So V value you need to find. So if the unknown value, no need to apply the symbol. Next what? Focal length. Focal length value always is going to be negative. Is that correct or not? Just now I told you F value, V value, you all will be negative for concave mirror. U value negative, V value, F value positive for convex mirror. And next, what is the U, Nana? 10 centimeter away. So that minus 10 centimeter. Compulsorily you need to apply the symbols. Okay, what is your mirror formula? 1 by F is equals to 1 by U plus 1 by V. This is your mirror formula. Try to draw a ray diagram for this accordingly. This is your principal axis and he said concave mirror. Focal length how much he said? 5. So this value is going to be 5. Where the object is placed? Where the object is placed 10 centimeter away from the concave mirror. So double of the focal length gives you a center of curvature. So that means this is your center of curvature. He said 10 centimeters. So you have placed your object at C because of 10 centimeter away. 5 centimeters focal length. Because you have a relationship R is equals to 2F. Radius of curvature is going to be double of the focal length. So R is equals to 2F. Let us substitute the values 1 by F. So 1 by, and already you have understood that. When you have placed the object on the center of curvature, image has to be on the center of curvature. What are the characteristics will be? Real, inverted, equal in size as per yesterday's concept. Okay, 1 by F. What do you mean by the 1 by F, Nana? 1 by minus F. Next, 1 by minus 10 plus 1 by V. Am I right? Because you need to apply the symbols along with. So we can write it as minus 1 by F is equals to minus 1 by 10 plus 1 by V. 1 by V is equal minus 1 by 5 plus 1 by 10. Because of minus 1 by 10 to the terms to the next step becomes a positive. What is your LCM? 10 is your LCM. 5 ones are, 5 2s are. So minus 2 plus 1. What did you get? Minus 1 by 10. V is equals to what, Anna? Minus 10 centimeters. So V is equal to, take it as a 10 centimeter. Symbol indicates which type of mirror it is. So you have got the image distance as 10. This is what exactly. So what will you write? So U is equals to V. Then image is real, inverted and equal in size. The total part is done. First chapter questions. And if possible, try to draw the ray diagram also. You need not to draw the race over there. Just try to mention where you're going to be placed. Take the other question to understand clearly. Where will be the object placed if its image is formed at 20 centimeter away from concave mirror whose focal length is 10 centimeter. Sorry, 15 centimeter. Okay, again, try to write the data given. Now he is asking where will be the object placed. Where will be the object placed? So U value you need to find. And the image is formed at 20 centimeter away. V value is going to be minus 20 centimeter. And F value how much, Nana? Minus 15 centimeter. I repeat, for concave mirror, U, V, F all are negative. For convex mirror, U negative, V, F positive. Let's again try to draw the ray diagram. This is your principal axis. And this is your pole. And somewhere else. What is the focal length is given? 15 centimeter. So this is going to be 15 centimeter. Where the object, this is your C. So this is 30 centimeter. Am I right or wrong? Because double of the focal length will be center of curvature, radius of the curvature. Now image where is formed? Image formed 20 centimeter away. 20 centimeter away in between 15 to 30, somewhere here. But that is image. Okay. Now he is asking where the object should be placed. Is that clear, everyone? This is the way of drawing the ray diagram. First to focal length you should write. And double of the focal length always gives the center of curvature, so it is the radius of the curvature. Now you have placed 20 centimeter. 20 always lies between 15 and 30. Somewhere you can place, not exactly 20. Okay, so you have formed the image is between. So object has to be beyond. Object has to be beyond. If the image is between, object is beyond. If the image is beyond, object should be between. So now you already understood that somewhere object has to be placed beyond the C. Okay, right, let's try. What is mirror formula? 1 by F is equals to 1 by U plus 1 by V. 1 by F. 1 by F means what, Nana? Minus 1 by 15. U value you do not know. And this is 1 by minus 20. Okay, is that clear? Now what will happen? Minus 1 by 15 plus 1 by 20 is equals to 1 by V. Yes, I transfer the 1 by 20 to the next side. What is the LCM for both? 60 is your LCM. Am I right? 50 and 20. Now 15 fours are, so minus 4. 23s are. You are 1 by V. So minus 1 by 60 is equals to 1 by V. V is equal to minus 60 centimeter. So say it as V is equals to 60 centimeter. So that object, what should an object with V value is going to be? Sorry, U value. Just it's U. Object has to be placed 60 centimeters away. You need to write the conclusion. So object to be placed at 60 centimeter away. Nidra baga vastunnatunnadi. 60 centimeter away. That's it. Now, if he wants to characterization, you can make it, because remember simple logic. If U value is greater than V, image always small. If U value is lesser than V, image always enlarged. I repeat you once again, if U value is greater than V, image will be small. If U value is lesser than V, image larger. And if U is equals to V, image same in size. You need to remember this. So you have understood always here U is greater than V, am I right or wrong? Because U is 60, V is 20. So always you can expect that image is always going to be small in size compared to the object. When U decreases, V increases. When V decreases, U increases. See, and one more thing, how to find out the focal length of a given mirror. Finding focal length of given mirror. Say it as a concave, for example. Why do you only take convex? Because it forms only the real image. We can characterize the real image clearly rather than virtual image. Okay, now he is given, for example, a mirror has given like this. You don't know its focal length. You need to find it out. So what are the requirements you have? So compulsorily one V-shaped stand, materials required. V-shaped stand and mirror and screen. Scale, candle. Say it as an object. You're going to take the candle as an object. Now what to do, sir? Let's take the V-shaped star to be at a certain distance, and you need to observe, place a mirror on this. Either side of your this, one side it is going to be a candle, and in between you are going to place a screen. Is that clear? You have given with the material V-shaped stand, mirror, screen, scale, candle. Screen is just a white paper because of the image has to be formed on it. Now you are going to take it as one V-shaped stand, another you have to take the given mirror, and the opposite to that taken a candle which works as a object. In between the candle and as well as the mirror you need to place the screen. And remember, first try to find out the distance between the, otherwise you can do one thing. Adjust the screen moving towards the candle or moving towards the mirror unless you get a clear image on the screen. Is that clear, everyone? It is not compulsory how much distance do we take, sir. Let's take a near above the distances such that mirror has to be placed somewhere else and quite opposite to that candle has to be placed. Now, in between the candle and the mirror, take the screen, try to adjust by moving towards the candle and towards the mirror unless you get a clear image. Unless you get a clear image. Now, once you get the clear image, stop moving the screen and try by using the ruler, try to find out the distance between the U as distance between mirror and candle, and V as distance between mirror and screen. Is that clear, everyone? Once you get the clear image, now try to stop moving the screen. By using the ruler, find the distance between the mirror and candle. Say it as a U because it's object, it's a mirror. And again find the distance between the mirror and screen, which works like as a V. Then substitute the values. 1 by F is equals to 1 by U plus 1 by V. So do we apply the symbol? Compulsory you need to apply this symbol because clearly he mentioned it's a concave mirror. If he does not mention, once the mirror is given to you, definitely by looking at it you can say whether it is a concave mirror or convex mirror. So sign convention rules are compulsory to apply to find out the focal length. If you do not apply the sign convention rules, you cannot get the focal length exactly. So this is a way experimentally how to find out the focal length of a given mirror. It may be a convex mirror, it may be a concave mirror. Based on the mirror, you will be applying the sign convention rules. I repeat once again, to find out experimentally finding the focal length of a given mirror, the materials are required V-shaped stand, mirror, scale, screen, candle, if the possible ruler. Simple, what we are doing, you have to take the V-shaped stand and place the mirror on it. And opposite to that, place the candle which is lighted and which works like an object. Take the screen to be placed between the mirror and the candle and try to adjust screen moving towards the mirror and as well as the candle unless you get the clear image. Once you get the clear image, using the ruler, find the distance between the mirror and the candle, say it as a U, and find the distance between mirror and the screen, say it as a V. By applying the sign conventional rules, substitute in the 1 by F is equal to 1 by U plus 1 by V. After your simplification, you will be finding the focal length. To have the focal length exactly, repeat the procedure for twice and thrice. Repeat the procedure for twice and thrice. Parallax error. Parallax error in the sense you may not find out the values because of your eye problem. So that is the reason to avoid that you need to find out the focal length by repeating the procedure twice or thrice. So for example, I will tell you in the first application you have got 1.5 something. In the second trial you might have got 1.6. In the third trial you may get 1.5 or 1.7. So by finding the average of them, you can find the exact value of a focal length. So this is the way how do you find out the focal length of a given mirror experimentally. I repeatedly informing you, sign convention rules must be applied. If you don't apply the sign convention rules, you may not get the value properly. And one more thing, repeatedly sometimes asking about the magnification question. If a mirror is given to you, whose magnification is going to be plus 2? What do you mean it? Question is like this, sometimes plus 1, sometimes plus 2, sometimes plus 4. So remember, always M is equals to V by U. Am I right or wrong? Forget about the minus. It is the ratio of the V and U. So V is going to be image distance, U is going to be object distance. Now what he gave 2, to understand easily, 2 or a fraction value compulsorily should be the 1 or less if it is a proper fraction. According to your mathematics, a fraction value should be 1 or less if it is a proper fraction. If the fraction value is greater than 1, if the fraction value is going to be greater than 1, what will you find? It is an improper fraction. Am I right or wrong? See, how do we understand, sir? For example, I written 2 by 4. Is it proper or improper? Is it proper or improper? It's a proper fraction. Simple logic, numerator is lesser than the denominator, it is a proper fraction. So, whatever the cancellation you do, you never get more than 1. See, 2 ones are 2, 2s are. So, you got as a 0.5. So, it's always lesser than 1. Repeat next. Say it as a 4 by 2. What will you get? What will you get? 2. So, then what will you say? 2 is greater than 1. 2 is greater than 1. Same way here also you are applying 2 in the sense automatically after the simplification you got the 2. Okay, so what do you understand then? 2 as the magnification value is 2, image distance is greater than the object distance. Image distance greater than the object distance. So V is greater than U. Definitely if V is greater than U, what can you say? Image is going to be larger than object. Image is going to be larger than object. That's it. And if you get as a plus, is it concave or convex? Is it concave or convex? Convex it is. And how it is possible, sir? M value is going to be minus V by U is given. Always in the concave, V value will be minus V. In the U will be minus U, minus get cancelled. Again remains with minus. If it is convex, what will happen? Minus remains in, V value is going to be positive. For what? Convex. U value is going to be negative. Minus cancel. What do you get? Plus V by U. But most of the cases they don't ask you what type of mirror it is. They will ask what type of image it is. Is it clear? By asking like question plus 2, plus 3, plus 4, they will be asking what type of image and characterize the image. But 99% remember, if it is a plus, definitely remember it is a convex. If it is a minus, definitely it is going to be a concave. This is what I repeatedly asking. Along with these questions, and one more beautiful question is asking, if spherical mirrors are not invented, what are the consequences? Or what are the uses of the mirrors? Both are same questions. If spherical mirrors are not known, what are the consequences? Means what are the problems? Otherwise, what are the uses of the mirrors? You can read them and you can write. This is the first chapter, repeatedly asking the questions. And also, last and the least one, solar cooker. What is an application of a solar cooker? Solar cooker is working under the application of converge. Solar cooker is working under the application of converge. How do then? All the concave mirrors are going to be arranged like a dish antenna, such that all the sun rays are going to be acting there. They will be centered at a common point, such that, as we all know, that sunlight not only gives the light but also gives the heat. So that means you are going to arrange all the concave mirrors like a dish antenna, like a half spherical or hemispherical. What will happen? Or you have to arrange them such a way all the light rays are going to be centered at a common point, like your magnifier. As you all know that magnifier, when you are moving the magnifier moving away and near, you may get the small dot. So when you get the small dot, heat is going to be more. When the dot increases, when the dot becomes wider, the heat is going to be reduced. Did you play or not? I don't know, but everybody used to play with magnifier. When you are moving the magnifier top and bottom, what will happen? Where you get the smallest dot, there the heat is going to be more. So here has been application. Solar cooker is working under the principle of converge of the light. You need to arrange all the concave mirror like a dish antenna or a hemisphere, such that all the light rays are going to be reflected and centered at a common point. At that common point, you are placing your bowl. So by using the application of the heat of the sunlight, you may cook or whatever it may be. So this is what exactly happened in the solar cooker. And other one also, rear view mirrors. One more important question here. We use only the concave mirror rather than, convex mirror rather than the concave mirror as a rear view mirror. Wherever you go to observe automobiles, there will be a side mirrors are there. Even in the car's back mirror, rear view mirror is there. Why do we use only the convex mirror instead of the concave mirror? The simple thing is, when we use the concave mirror, image is going to be formed behind of observer. When we use the convex mirror, image is going to be formed opposite to the observer, so that he can see clearly what is happening behind. Simple technique. We use convex mirror as a rear view mirror. Image is going to be formed opposite to the observer. If we use the concave mirror, image is going to be formed behind the observer, so that we cannot see behind the vehicles. This is the reason generally which will apply. So overall, the total reflection is depending on this. Applications are important in the physics rather than buttifying your answer. They are not asking here write a lengthy answer, but even in physical science also. And don't try to the stories in the physical science. Write the answer point to point, whatever he is asking. That is only the matter. If you know the answer properly, it's better to write point by point. If a long answer question is given, 6 to 7 points are enough, which concludes entire the answer. Conclusion is the matter. Instead of writing para wise, try to write the point to point, so that you will get the good marks. And this is your first one, reflection of spherical mirrors, right?